Hi, my name is P3, working at Hyundai Motor Company. In this talk, I'm going to introduce Guider, a new performance monitoring daemon, and explain how to use it. This is a summary for my talk. First, talking about tools for performance analysis. Next, introducing Guider and its various features. And finally, explaining how to monitor performance of our systems automatically using Guider. Logging and using tools are most effective way to analyze performance. Logging is very useful for recording specific information, but understanding logs require domain-specific knowledge, so system-level engineers or new members are difficult to understand them usually. In addition, adding new logs require source code and toolchain for rebuild. It's very boring and time-consuming job. So it's also difficult to record and analyze too many logs because of the limitation for memory and our time. So we prefer to use performance tools. It's very comfortable and effective to analyze performance at system level usually. As shown in this picture, there are already many performance tools in various areas, but sometimes too many tools confuse us. Determining the right tool from a variety of performance issues is not easy. Even though they are not all installed in our system, so we should install them in manual, but they may require latest kernel and libraries, dependent packages, more kernel configurations. After installing them, even it require rebuilding the target program, restarting target tasks, loading kernel modules. There are too many limitations. So I introduced Guider, Unified Runtime Performance Analyzer. It can monitor, profile, trace, visualize various performance factors, and it also contains many embedded units. Now it consists of about 135 commands and each options. Monitoring features provide continuous performance stats every interval in real time. Profiling features provide a statistic overview of collected data during a specific interval. Tracing features provide specific data on the execution of the task in the form of logs. Guider is a kind of command line interface tool. So it offers a lot of features by the combination of commands and options. But in this talk, I will try to explain only some useful features because of time limitation. It's open source program and written in Python. It doesn't require installation, but pip and yocto recipe are also supported for your convenience. Actually, just executing guider.py file is enough. Guider never uses external binaries such like executable programs, libraries, Python packages, except for matplot for some kind of visualization features. Most of Guider features are implemented directly using standard library such like libc. That's the reason why Guider doesn't require rebuild, install, configuration. In addition, it can be applied with only 1 megabyte of storage space. These characteristics are very attractive in embedded systems. All features of Guider are supported in Linux and Android, and it also provides some limited features on macOS and Windows. So from now, let me introduce some killing features of Guider. First one is monitoring system resources in real time. This feature works by periodically updating states for system resource and events. System resource is about CPU, memory, swap, block, network, storage. As shown in the picture, in the first part, system resource information is shown on the top line, such as the number of core, RAM, and swap. In addition, system information such as context switching, interrupt, running task, memory zone, and performance stats using PMU are also displayed. Task, memory zone, and performance stats using PMU are also displayed. In the second part, important system-level resources and events are displayed. System states such as CPU usage, available memory, swap usage, memory reclaim, block I/O, network I/O are most precious information for performance analysis. In addition, per core usages are also displayed, although not shown in the picture. Governor, clock, temperature for each core can be shown together using specific options. In the third part, storage information about busy, workload, available space is shown for each device. Heavy storage workload can cause serious performance degradation. That's the reason why we check those stats. In the upper part of the picture, network information about inbound and outbound is shown for each device. In the lower part of the picture, not only system resources, but also task resources are shown with their attributes in real time. It's a little bit smaller to Linux's top command. Usages for CPU, virtual, physical, shared memory, swap, block I/O, and memory details are displayed well. The shown tasks are sorted by CPU usage in default, but you can change the sort order using specific option. All or specific function calls are monitored for specific tasks in real time. In addition, stats about function calls are also displayed, such as average, minimum, maximum time. At this picture, all function calls are shown with backtrace. That usage is not about CPU. It's the proportion for the total function calls. So this feature is useful when finding frequent calls or measuring specific function call count, including backtrace. Of course, this is another function monitoring feature to measure CPU incentive function calls by sampling techniques. All syscalls, including backtrace, are also monitored for specific tasks in real time. In addition, syscall states are also shown, such as elapsed time, error return together. This feature is very useful when finding syscalls that takes a long time, measuring specific syscall count, checking syscall error returns. The tracing feature for native functions such as C, C++, Rust, Go is provided. Native function tracing is started by bittrace command. The command is implemented using breakpoint called trap. Breakpoints for all symbol addresses from ELF and dwarf sections are injected to the target task's virtual memory by Guider itself. So Guider can detect events for function call and function return from the target task using ptrace. Guider can even read and manipulate registers and memory for the target task when function events occur. As shown in the picture, call stacks are shown with various depths for Go program in real time. Arguments and binary name for each function are also displayed together in a line. Next tracing feature is about Python function. Python function tracing is started by pytrace command. The command will print all Python method calls. As shown in the picture, Python call stacks are displayed in real time at various depths depending on the stack frame, File path and line number for each function are also displayed together. The target was IO type program that written in Python and prints IO uses in real time. Next tracing feature is for syscall. Syscall tracing is started by strace command, similar to original Linux command. The command will print all syscalls and their arguments covered into an easy-to-understand format. As shown in the picture, syscalls are displayed with backtrace, return value, elapsed time in real time. Text-based analysis is specific but less readable. That's the why guider provides visualization features in SVG format. Using the SVG format output in your web browser, it provides an easy-to-view and responsive interface. First visualization feature is about resource graph. As shown in the picture, the top box shows graphs of CPU usage for processes. The top box on the right side is the label list for the CPU graphs. The middle box shows graphs of block and network I/O for the whole system. The bottom box shows graphs of memory for the whole system. Of course, process graphs about block, network, memory resources are also available. In addition, filter option for all of them is also supported. As you can see, this visualization feature makes it easy to understand big data collected for a long time. And it also helps to understand trends in resource usage. And this is also good for communication with other people. Next visualization feature is about scheduling. The scheduling data is very large and very difficult to analyze one by one. Therefore, as shown in the picture, scheduling data such as time slice, preemption, and blocking should be visualized prior to detailed analysis. Using the SVG format output in your web browser, you can view details for time slices. It's very effective for analyzing multi-threaded programs, interactive services, delayed tasks, core utilization. In addition, this feature also allows for scheduling events as well as other custom events having timestamps for start and end. Last visualization feature is about call stacks. Analyzing only last called functions without whole call stack is difficult because standard functions such like read, write can be called by any other functions. Above all, in most cases, last called functions will not cause all the problems. The problem is likely some other functions that called these last functions. Therefore, to analyze performance problems in function level, we need to be able to see the full, including each call stack. In this case, this flame graph feature is very useful to analyze call stack-based profiling results for CPU usage, blocking status, memory rates, syscall trigger, function call. As shown in the picture, last functions at the bottom of each stack are various, so we need to analyze upper functions that contains them. I guess modifying those functions will improve your application or service performance actually. Opening the SVG format output in your web browser, highlighting, zooming, searching specific functions or stacks are also available using mouse and keyboard. So far, I have explained how to analyze problems that have occurred. However, how to analyze problems that are not well reproduced or had complex conditions, sudden stuttering, screen freezing, system reset, audio chopping, slow app launching, or switching. These kinds of problems are difficult to analyze using some simple logs and often require system-level information, especially for temporary problems that occur suddenly and disappears. There is no time to try to analyze something by connecting a terminal. Sometimes there are potential problems that are not even visible to the naked eye. How can you analyze these problems easily, and quickly, and accurately with minimal effort? For this purpose, Guider runs as a system daemon at all times and monitors system status and activities. And based on a threshold for a predefined resource or event, specific commands are automatically executed to handle them. The specific operation is shown in the figure. First, Guider daemon loads the config file during initialization and registers resource thresholds for each defined event and commands to handle them. After that, the target resource uses and other states are periodically saved and checked, and if the status meets the condition of specific events, then events are generated. When events occur, the guider sequentially executes the commands registered for the events. In addition, a separate report file is created and stored in the storage by summarizing the stored system information, including resource uses. This allows you to automatically handle problems with predefined commands when a specific problem occurs or start problem analysis with a generated report. These functions, which works all the time, are usually performed using a small amount of resources of about 1 to 5% per second based on one CPU core. It's very lightweight and suitable for embedded systems as well. In the demo, the occurrence condition of each event is defined as the threshold value of each resource defined in advance through the config file. Each event is largely classified into system, task, and device units. System type attributes are defined for system-wide resources. Task type attributes are defined as all or specific tasks. Device type attributes are defined for specific storages or network devices. In the case of resources, as well as hardware devices such as CPU, GPU, RAM, storage, and network. Logical resources and states such as block, system load, file descriptors, sockets, and in-storage files are also included. In addition, various types of logs, functions, and IPC messages are also available to be monitored. Inside Guider, a lot of resource and statistical information is uploaded in real time, and it's continuously checked to see if there are any events that exceed predefined thresholds. Some of the information collected inside the Guider is displayed on the screen. The command to be executed when an event occurs through the config file can also be defined. Please look at the config in JSON format on the right side of screen. Events of system and task are defined for CPU resources. The attributes of each event include threshold values such as total and a list of commands to be executed when the event occurs. Through the system part defined at the top in the JSON data, if the average system CPU usage exceeds 95%, the save command is executed and guider creates a report file based on the information it has been being stored in the buffer. Through the task part defined at the bottom, when the average CPU usage of a specific task exceeds 95%, the cmd top command is executed and guider starts monitoring for all threads of the target process and saves the result in the specific file. In this way, when each event occurs, the commands defined in the command list are executed sequentially and in parallel. These commands may be predefined in the log file. It can also be a user-defined command that the user can execute immediately in the shell. In addition, various functions provided by Guider can be easily combined and used as event handling commands. All of this is done by Guider itself without installing any separate packages or relying on any particular system. As shown at the bottom of the screen, when an event occurs, the name of report files are automatically generated, have a regular format. All the files start with the execution order and number of reports, and the resource, occurrence range, threshold value, and time information of the event that generated the report are added to the file. In default, each report is just text file, but it can be compressed and generated according to the guided execution options. The reason that the compression function is supported is because report files are automatically created in the background, so storage can be excessively used when many files are created. In addition, if you use the option of the maximum size of directory where report files are created, the daemon tries to maintain the specified capacity by erasing the oldest one if a new report file is created that exceeds the specified size. This is very important. It is very important for math production in embedded world. From now on, I will explain the report file that is automatically generated when an event occurs. At the top of the report file, information like the picture is displayed. Execution options, versions, runtime, load, number of tasks, kernel command line. This information helps to understand each system and execution options through report files generated in various environments. The following is information about system resources, information about RAM, storage, network, and other things is displayed. It displays the system resources at the time the report was generated, as well as the resource at the time the daemon was first launched. Using this, you can see the approximate resource changes and easily determine the resource available at the time of event creation. If the previous page showed the snapshot at the time of the event as shown resource table, From now on, based on the information stored in the buffer before the event occurs, it shows the amount of resource change in each section for a long time. For example, the top summary table shows the system resource usage line line by line for each segment. Displays various resources such as CPU, memory, block, swap, reclaim, fault, context switching, interrupt, number of tasks, network, and other things. Can you see the resource change? And next is the top CPU info table. From here on, the CPU usage of threads is displayed in units of intervals according to each process and option, not the system. It also displayed the minimum, average, maximum, and total stats for each process's CPU usage. This is very useful for detecting steady CPU usage or sudden bursts of CPU usage for specific tasks. The resource table of these process units is not only CPU, but also VSS, RSS, delay, I/O, C group, and other things. When analyzing a report, it can be useful from several perspectives. Finally, the part that shows the most specific information, it shows detailed event and resource information that occurred in each section. Based on the previously summarized information, it is information that can be referenced when you need specific information on a specific section. In particular, the information of the processes is specified, and it's possible to check how much each resource is used in which area. And there are cases when it is necessary to control the daemon under specific circumstances. At this time, since the daemon operates in the background, commands cannot be sent to the standard input. So the guider provides an event command separately to control the background daemon. This command is originally used to generate a specific event, but if a string started with CMD is used, it is interpreted as a command to be passed to the daemon. The command to be delivered to the daemon is as shown in the figure. There are buffer size change, buffer initialization, monitoring stop, activation and deactivation of monitoring for specific resource, change of monitoring cycle, config reload, forced report generation, daemon start, and other things. So far, I have explained some kind of useful features, including trace and monitoring of guider. There are more useful features besides the ones I described, but I couldn't explain all of them because of time limitation. And I introduced the performance monitoring daemon feature. It will be more expanding to be managed and analyze performance issues itself. For specific details, please refer to the README file in Guider repository and GitHub. And if you have any questions, please contact me using email or GitHub. Thank you for your listening. Thank you.